Welcome back to Science to Sleep By. Tonight, we are going to take a slow, thoughtful journey through one of the most fascinating questions in all science. Is there really a center of the universe? It's the kind of question that feels simple at first, but as we begin to explore it, we'll find ourselves drifting through galaxies across unimaginable distances and into the very structure of reality itself. So settle in, get comfortable, and let your mind gently wander as we explore what scientists have discovered about the vast universe we call home. When we imagine the universe, many of us instinctively picture something like a giant sphere, perhaps with stars and galaxies scattered throughout, and naturally, we assume there must be a center, some special points from which everything begins. This intuition comes from everyday experience. After all, most things we encounter have a center, a circle, a room, even our own bodies. But the universe doesn't behave like the familiar objects we interact with daily. According to modern cosmology, the scientific study of the universe's origin, structure, and evolution. The universe doesn't have center in the way we might expect. This idea stems largely from observations of cosmic expansion, first discovered in the early 20th century. Astronomers noticed that distant galaxies are moving away from us, and not just in one direction but in all directions. At first glance, this might make it seem like we are at the center, but when scientists look closer, they realize something remarkable. No matter where you are in the universe, it appears that everything else is moving away from you. This is because space itself is expanding, stretching like the surface of an inflating balloon. Importantly, the surface of a balloon doesn't have a center on its surface. Every point moves away from every other point as it expands. In this analogy, the true center would exist in the higher dimension, not within the surface itself. Similarly, our universe may not have a center within the three dimensions we can observe. This concept can feel abstract, even unsettling, but it reflects one of the core principles of cosmology. The universe is homogeneous and isotropic on large scales, meaning it looks roughly the same everywhere and in every direction. As we ease into this idea, it invites us to let go of need for a central point and instead embrace a universe that is far more evenly disturbed and subtly structured than our intuitions might suggest. To understand why scientists believe there is no center point in the universe, it helps to think more deeply about the nature of Big Bang. Contrary to popular imagery, the Big Bang was not an explosion that occurred at a same point in the empty space. Instead, it was an expansion of space itself, happening everywhere at once. Every region of the universe was once compressed into an extremely hot, dense state, and as time progressed, space began to stretch, carrying galaxies along with it. This means that every location in the universe can trace its history back to that initial state, not because they were all at one location, but because the entire fabric of space was condensed. Imagine baking rising bread as the dough rises in the oven, the raisins move away from each other. No single rising is at the center of the expansion. Rather, the expansion happened throughout the dough, From the perspective of any rising, it appears that all others are moving away. This analogy closely matches what astronomers observe when they measure the redshift of distant galaxies. The stretching of light that indicates they are receding from us, the further away a galaxy is, the faster it appears to be moving away, a relationship known as Hubble's law. This observation supports the idea that space itself is expanding uniformly, not from a central point within the universe. For an audience accustomed to thinking in terms of maps, coordinations, and central locations, this can feel counterintuitive. We often rely on reference points to orient ourselves, but in cosmology, the absence of a center is not a limitation, it's a profound feature of the universe. It suggests that no place is inherently special or privileged, reinforcing a humbling yet beautiful idea. Wherever you are at the center of your observable universe, simply because that is where your observations begin. Another important concept that helps clarify this idea is distinction between the universe and the observable universe. The observable universe refer to the portion of the cosmos that we can see, limited by the speed of light and the age of the universe. Light from the distant galaxies takes billions of years to reach us. So when we look into space, we are also looking back in time. The observable universe form a kind of sphere around us with Earth at its center. But this doesn't mean we are at the center of entire universe. Instead, it reflects the limits of our perspective. If you were located in a distant galaxy billions of light years away, your observable universe would also appear centered on you, containing a different set of galaxies. This idea reinforces the notion that the universe has no unique center. It's a bit like standing in a fog. Wherever you stand, the visible region surrounds you equally in all directions. But that doesn't mean the fog itself has center at your position. Scientists use powerful telescopes to map the large scale structure of the universe, revealing vast cosmic webs of galaxies, clusters, and voids. These structures extend far beyond what we can directly observe, suggesting that the universe continues well past our observational horizon. Some theories even propose that the universe may be infinite, in which case the concept of a center becomes even less meaningful. An infinite universe would have no edges and no central point, much like an endless grid extending in all directions. Even if the universe is finite, it would still be unbounded, similar to the surface of a sphere where you can travel indefinitely without encountering an edge or a center. These ideas challenge our everyday understanding of space, but they are grounded in careful observations and mathematical models that have been tested over decades. As we reflect on this, it becomes clear that question of our center may not apply to universe in the way we initially imagined. The geometry of universe plays a crucial role in the discussion. Scientists study the shape and curvature of space using observations of cosmic background radiation, the faint afterglow of the Big Bang that fills the universe. Measurement of this radiation suggests that universe is remarkably flat. On large scale, meaning that the rules of Euclidean geometry, the kind we learn in the school, applying across vast distances. In a flat universe, parallel lines remain parallel, and the angle of a triangle add up to 180 degrees. This flatness has important implications for the concept of a center. In a flat, infinite space, there is no natural point that can be identified as the center. Every location is equivalent and there is no preferred direction or position. Even in the models where the universe has curvature, either positively curved like a sphere or negatively curved like a saddle. The idea of a center within the space itself doesn't necessarily emerge. For example, the surface of a sphere is finite but has no center on the surface. The center exists in a higher dimensional space. Similarly, if our universe has a more complex geometry, its center might not exist within the dimensions we experience. Physicists use sophisticated equations derived from general relativity to describe how space and time behave under the influence of gravity and energy. These equations allow for a wide range of possible cosmic geometries, but none require a central point within the universe itself. For the listener, where science educated often emphasizes clear definitions and physical intuition, this can be a moment to appreciate how advanced scientific understanding sometimes move beyond intuitive models. The absence of a center is not a gap in knowledge, it's a conclusion supported by a consistent framework of theory and observation. It invites us to expand our thinking and accept that the universe may not conform to the pattern we expect from everyday experience. As we continue this journey, it's worth considering how this idea fits into the broader history of science. For centuries, humans believed that the Earth was at the center of the universe, a view known as the geocentric model. This perspective was deeply rooted in the observation. After all, the sun, moon, and the stars appear to move across the sky while Earth feels stationary beneath our feet. It was not until the work of astronomers like Galileo Kepler that this view was challenged and eventually replaced by the heliocentric model, in which Earth orbits the Sun. Later discoveries reveal that our Sun is just one of billions of stars in the Milky Way galaxy, which itself is only one of countless galaxies in the universe. Each step in this progression has moved us further from the idea that we occupy a central or spatial position. The realization that the universe has no center continues this trend, emphasizing a principle known as Copernican principle, the idea that we are not in privileged or unique location in the cosmos. This principle has been remarkably successful in guiding scientific inquiry, leading to the models that accurately describe the behavior of galaxies, cosmic expansion, and the distribution of matter. For a modern audience, especially in the country like the United States, where innovation and exploration are deeply valued. This perspective can be both humbling and inspiring. It reminds us that our place in the universe is not defined by centrality but by our ability to observe, understand, and explore. The absence of a center doesn't diminish our significance. Rather, it highlights that universality of laws of physics and the shared nature of cosmic evolution. Every galaxy, every star, and every observer participates in the same grand expansion, connected by the fabric of space time itself. So, is there really a center of universe? Based on everything scientists have observed and understood so far, the answer appears to be no. Not in the way we typically imagine. The universe doesn't expand from a single point within the space, and it doesn't contain a central location that can be identified as special or unique. Instead, every point in the universe participates equally in its expansion, and every observer sees themselves at the center of their own observable region. This idea may feel unfamiliar at first, but it reflects a deeper truth about the nature of reality. The universe is not structured around us, yet we are fully part of it. As you let this thought settle in, consider the quiet elegance of a cosmic without a center, a universe that stretches endlessly, evenly, and beautifully in all directions. There is something deeply calming about this perspective. It invites us to release the need for a focal point and instead appreciate the vastness and symmetry of existence. As you drift towards sleep, imagine the gentle expansion of space, the slow movement of galaxies, and the steady glow of ancient light traveling across billions of years to reach us. In that stillness, you are not at the center, but you are exactly where you are meant to be, part of same unfolding universe as everything else, and that in its own quiet way is more than enough. Good night.